Now finally we get down to the transport layer. The transport layer is one that as networking professionals we are very concerned with, and so we will spend a little more time on this one than we have on some of the others. The transport layer controls end-to-end communication. What do we mean by that? Well, the applications, the server and client applications that move different kinds of traffic have port numbers associated with them. And that port number tells that data when it gets to that receiving computer what application should receive it. And so it's really end-to-end. In other words, we start with the application on one end, we end with the application on the other end. So that's why we say it's end-to-end. And then also it has a sequence number in it, at least some does. If it's TCP anyway, has a sequence number to provide flow control so that each segment has a number associated with it, and if it's missing any numbers when it gets done with receiving the data, it knows to go back and get the missing segments again. So TCP traffic does that. Now UDP is another transport layer protocol, and it does not have sequence numbers. It doesn't need them, and we'll see why in just a little bit. The PDU now is called a segment. And it's called a segment now because it's been chunked up, first of all. A certain amount of data has been grabbed and then headers put on that package of data, so which we now call a segment. Here are the parts of that header. You can see that the important ones here are the source port, the destination port, and then a sequence number. Now the acknowledgement number is also part of a sequence number, but it's kind of a response number that it uses in order to communicate back with the sending device. But the important ones here are the fact that it has a source port and a destination port, and then that sequence number in the case at least of TCP traffic. Remember too that the sequence number does not exist in UDP traffic. By far the most common transport layer protocols and the most important ones are TCP and UDP. TCP is Transmission Control Protocol. This is what we call connection oriented, and it is guaranteed delivery. It's connection oriented because a handshake has to take place in order for a connection to be made. And once that connection is made, then the transmission can move from one end to the other. It's also guaranteed delivery in that it has those sequence numbers, and if a sequence number is missing, it knows I need to go back and get that segment. UDP is used for things like streaming of data, user datagram protocol, and it is not connection oriented. It just simply sends the data, and if the receiver receives it, it does. If it doesn't, it doesn't. This is used in things, for example, streaming of a movie. You don't want, just because a pixel is missing, you don't want the thing to stop and go back and get that pixel. You'll simply get a distorted image, slightly distorted image. And so it's at the human layer that we discover that there's a problem, not inside the, in other words, error correction does not take place at the computer level here. We simply receive it. So these are by far the two big protocols that we use in the transport layer. That's it for the transport layer. In the next video, we'll talk about the network layer.